Mm-hmm. All right. And if you're in Miss Fletcher's class, if you have a question about one of these that I need to go over, if you'll send a message in the chat, that way I'll know to go over it. I'll check periodically and see. All right, so here are the answers to 1, 2, 3, and 4. Number 1 is 130 grams. Number 2 is 40 grams. Number 3 is 70 grams. And number 4 is NaCl, which is sodium chloride. Does anybody need me to show you how I got these answers, 1 through 4? All right. Let's go to the next answers. Now, there is something I should have changed on this part of the worksheet. I'm so sorry. Down here, when it says 50 milliliters of water, it should say 100. You can answer questions with different amounts of water, like even though your graph is 100 milliliters, you can answer for 200 or 50, but you do not have to do that for this class, so I should have changed that to 100. So this is how we would answer it for 100. I think most of you probably didn't notice that change, so it's not a big deal, but if you did, I'm sorry. I apologize. On number 2 then, the box, oh, up here? Okay, so somebody needs us to go over number 4. It says, which of the above 3 substances is most soluble at 15 degrees Celsius? And we have KNO3, NaCl, and NH4. Let me make this bigger. Was it 15 degrees? Now I've already forgotten. You see it? Okay, never mind. Good. All right, and remember Miss Fletcher's class, type in the chat room if type in the chat room if you need me to go over one. I don't mind doing that at all. All right. Does anybody need me to go over something in box number 2? All right. Here is number, oh, I'm doing too much. Here is number 3, 4, 5, 6, and 7. Let me make this bigger and just do 3. That will help probably. So number 3 is approximately 28. Remember, you can be a little bit high, a little bit low. That's fine. 3B, approximately 35. 3C, approximately 14 grams. 3D, approximately 5 grams. Any questions on 3? All right. Number 4 is unsaturated. And number 5A is unsaturated. And then 5B, 34 degrees Celsius because too much solute to dissolve. Once you get to around 34 degrees Celsius, that means it's going to start falling out of solution. Number 6, we have Ki, potassium iodide, is the most soluble. And the least soluble is cesium sulfate, which is Ce2SO43. And then number 7 is KClO3. Anybody have questions about anything on the front page? Okay. Number 8. 50 grams because 130 grams is soluble at 70 degrees and we only had 80 grams. So that means we can add 50 grams to be saturated. Any questions about anything on this worksheet? We're going to be doing a quick check on solubility curves in just a little bit. So if you have questions, let me know. All right, let's go and work on reviewing our video from acids and bases. Yes, later before we do it, because they didn't do it in the other class, so I don't want to waste their time. Does that make sense? And we can go over it in just a second. We may even have to do it tomorrow because I may have to check off who's done it so that if y'all need to unsubmit it and change it, I already know who did it. So we may have to look at it tomorrow. I mean, not tomorrow, Monday. Okay. So first of all, let's do some general things about acids and bases, some general information. First of all acids and bases are solutions. That's why we're talking about them in this unit. The pH scale allows us or helps us measure acidity, which is acids or how acidic something is, and alkalinity, which is how basic something is. You need to be familiar with the word alkaline, alkalinity, just in case you see it, because it does represent a base. So just know that alkaline means the same thing as basic or a base. Now, there are two indicators actually, no, I'm going to change that to 3 of indicators that we can use to tell us if something is an acid or base. So an indicator is something we use to tell us if a solution is acidic or basic. So something we use to tell us if a solution is acidic or basic. So our first type of indicator is litmus paper. Now, there are two types of litmus paper. We have red litmus paper and blue litmus paper. Oop, spelled that wrong. We're going to talk more about these in just a minute. Does somebody in Miss Lou's class want to put that paper towel roll down so that y'all, I feel like that's going to be annoying for y'all. Red litmus paper and blue litmus paper. And they can only tell us if the solution is acidic or basic. That's it. Some of the other ones will be more specific. And on Monday, I'm going to show y'all what litmus paper looks like. The second type of indicator is pH paper. And this is like a light tan or light yellow color. This can tell you what pH your solution is at. So you can actually learn from pH paper that your pH is somewhere in between 3 and 4. Okay, like you'll be able to tell a more specific number. And then our third indicator is a pH probe, which is a digital probe similar to a thermometer that you can put into a solution and it will give you, so let me write what it is, a digital probe. It is not a thermometer, but it's like that, where you can put it in something, a solution, and find the temperature of it. That's what thermometers do. This one, you can place it in a solution and you can find out the pH of it. And it can specifically tell you an exact pH. For instance, pH paper, you'll know it's between 3 and 4 or around 3 or around 4. With a pH probe, you can know that the pH is 3.3 or 3.4. So it's much more specific. So as you move down this list of indicators, they become more specific and more detailed. All right, now let's compare acids and bases. So acids taste sour. Now, obviously, we do not taste things in the labs. So when we refer to acidic things that taste sour, we're talking about food, like acidic food. Vinegar, tomatoes, citrus fruits, all of those taste sour. Now, bases taste bitter. And a lot of what we're going to talk about in regards to acids is going to be opposite for the bases. Oh, wrong color. Now, acids, still wrong color. Acids feel watery or squeaky. Like, for instance, when you put them in between your fingers, it's thin like water and it kind of is a little squeaky. Bases feel oily, like smooth. Again, we do not touch acids and bases in the lab unless instructed to do so, because chemical acids and bases can be very harmful. Acids, I'm not going to do that one yet. Acids start with an H in their chemical formula. For example, HClO4, HF, H2SO4. These are examples of acids, and they all start with H. So that is kind of a clue that you can use. They all start with hydrogen. You can use that clue to help you determine if something is acidic or basic from their formula. Now, bases end with an OH group in their chemical formula. For instance, KOH, LiOH, MgOH2. But they all end in OH. So those are some ways you can tell them apart by their formulas. Now, strong acids and strong bases fall apart when they're in formula or in solution, which I'm going to tell you about in just a second. We're going to write that down. when they fall apart, the acids have their H's come off, and the bases have their OHs come off. So since the H's fall off, we say that acids add hydrogen ions to solution. So when you put an acid into solution, into water, it's going to add hydrogen ions, and H plus means hydrogen ion. The bases have the OH groups fall off, so they add hydroxide ions to solution. And OH negative is hydroxide ion. Now, if you are using litmus paper to test something and it's acidic, it's going to turn litmus paper red. Now, we said that we have red litmus paper and blue litmus paper. So if you put the blue litmus paper into an acid, it will turn red. If you put the red litmus paper into an acid, it will stay red. Okay, it won't turn red because it's already red. But bases turn litmus paper blue. Again, we have a red and blue piece of litmus paper. If you put the red litmus paper in a base, then you're going to see it turn blue. If you put the blue piece of litmus paper in a base, it'll just stay blue. All right, so let's look at examples. Oh, no, actually, I have a couple more things. I'm sorry. Some things that are the same, and I'm going to color them as purple. Anybody know why I would choose purple? Yeah, together. So things that are the same for acids and bases, strong ones can be corrosive. And what I mean by corrosive is they can burn you. They can eat away at metal, and y'all have probably even seen this done with your parents maybe. Whenever our cars won't crank or we're having battery problems, the first thing we do is to see if our battery cables are corroded. And has anybody ever poured something on it? Coke. Because what is Coke? It's acidic. It's strong acidic. It's strongly acidic. And so the acid can eat away at the corrosion. Does that make us nervous about drinking it now? It tastes too good for us to care about that, doesn't it? So strong ones can be corrosive, but they can also burn your skin. For my class, remember that demo we took outside and then had to take outside a second time? Remember that acid I had was very strong. When I was working on my chemistry degree, I had lab clothes because we worked with strong acids all the time. And if you got even a dab of strong acid on your jeans, there'd be a hole in it within like 5 minutes, because it would just eat through it. So acids and strong bases can do the same thing, because a really strong base, an example of one is bleach, right? Bleach can burn you. You can't get it in your eyes. It will burn your eyes. And so strong bases can do the same thing as strong acids. That is true. That's why we dilute it. And so also strong ones, we've already talked about this, but they can conduct electricity. They can conduct electricity. Another thing that they can both do, strong ones will completely dissociate. And that's what I was talking about earlier. If I say that I am completely dissociated from Lowndes High School, what does that mean? Yep, I don't deal with them anymore. I'm gone. I've left. It means they've come apart. So strong acids and strong bases will completely dissociate or fall apart in solution. That's why the acids will give a hydrogen, give hydrogen ions into the solution, and why the bases will give you hydroxy ions, because they split apart when you put them into water and into solution. And they're all solutions. All acids and bases are solutions. Now, we're almost finished. We just need to go over the pH scale and how to label it and how to tell some things from the pH scale and how to read it a little bit. And I'm going to show you everything that you need to know about the pH scale. So the pH scale goes 0 to 14. Does anybody know what 7 is? Neutral. Good. All right. And we didn't put this up there in our list, but you could put this like their pH range. I didn't put that, but we could put it. Oh, and we also didn't do examples. So I'll go back up. Let's go back up and do some examples real quick. So some examples of acids: vinegar, citrus fruits, oranges, lemons, pineapple. Anything that has H on the front, remember, it will be acidic. Like if they give you the chemical formula, we wrote some of those down. Soda. And then some examples of bases. Guys, all of your cleaners are bases. So if there is a cleaner at your house, any kind of soap or cleaner is always a base. The main ingredient of almost all cleaners, like household cleaners, is ammonia. And it's usually ammonium hydroxide is what we have and what creates it as a base. So any kind of cleaner, any kind of soap, even the soap you use for your hair and for to like take a shower, those are bases as well. Any kind of soaps and cleaners. Tums. Y'all don't need these yet, but what do your parents take Tums for? Upset tummy, heartburn. When you have an upset tummy or heartburn, that means also heartburn is called acid reflux. And it's because you have too much acid in your stomach and it's coming back up your esophagus. So Tums are a base because if we're too acidic, we need a base to bring us back closer to neutral, right? Our stomach's going to always be slightly acidic because of the stomach acid that has to be used in digestion, but the Tums will help bring it back closer to neutral. Hold on one second, because they're on with us and they can't hear y'all. So hold on one second and we'll come back to that. And remember also, if you're given the chemical formula for bases, they have OH at the end. But any kind of cleaners, soaps, oils, those are bases. Okay. So now let's look at this pH scale. Which side are our acids on? Left. And so that means on the other side is where we have our bases. Now, if you've ever been in like government class or history class and that's usually where you'll do like debates. If you're ever neutral about an argument, that means you don't really have a side, right? It means you don't care which side is right or which side is wrong because you're neutral about it. So that causes you to have a weaker argument when you're debating someone if you don't really have a strong opinion. So when a base is closer to neutral, it is weaker. These are where our weak bases are. So what type of bases do we have over here close to 13 and 14? Strong bases. Good. And then what type of acids do we have close to 7? Weak acids. Because they're close to 7, so they're going to be weaker. And then our stronger ones are going to be closer to 0. Because those acids are farther from neutral, so that means they're stronger. Now, what did we say acids release into solution? What did we say? Hydrogen. So which side do you think has a lot of hydrogen ions? The left. So over here, very high hydrogen ion concentration. We've already talked about concentration. It's how much of something we have. And so we have a high amount here. What about on the other side? How much hydrogen do we have? Not a lot. Because hydrogens are released from acids. So if we're on the basic side, you may have a little bit, but not a lot. So a lot of hydrogen on the left side and not a lot on the right side. Now, what about hydroxide ions? Where will we find a lot of those? In the bases. So high hydroxide ion concentration or amounts. You can put amounts if you'd rather that instead of concentration. And over here, low hydroxide ion concentration. So when we are moving 0 to 14, we are increasing hydroxide ion concentration and decreasing hydrogen ion concentration. And the opposite is true if we went from 14 to 0. So you need to be able to tell us where strong acids are, weak acids are. If you're given examples of, like, we have one solution at a pH of 3, one solution at a pH of 4, and one solution at a pH of 5, which one is stronger? You need to pick the lower number for acids. But the stronger ones are the higher numbers for bases. Okay? Any questions about that? We're going to do a lot of practice on this today. All right, so both classes, my class and Miss Fletcher's, if you will do me a favor and put up everything except your Chromebook, just put it under your desk. We're going to pull it out later, but we're going to do a solubility curve quick check. During a quick check, I do not want my class at the same lab tables, so you need to split up if you are going to be back there.